Welcome back, everybody. Mr. Wakefield here, looking at section 3.8 now, and we are starting out with something new here, but there's going to definitely be some similarities here. In the last few sections, we have solved one variable equations, okay, where the goal of solving one variable equations is to get x by itself, okay, and solve for x. What we're going to have here, and again, what makes an equation in the first place? It is the fact that it has an equal sign, okay? And you want to get the x by itself on one side of the equal sign so that the x also is not on the other side, and that's what it means to solve for x. The only difference here really, when you have a linear inequality, as it says here, again, it's a one variable thing, just like the equations I just talked about. But the difference with an inequality versus an equation is that it has one of these four inequality symbols. It could be any one of the four instead of having an equal sign. So there won't be any equal signs here, but there'll be one of these four instead. Okay, greater than, less than, greater than. Pardon me. This one's less than or equal to, and this one is greater than or equal to. Okay, so four different things here. That's how you read those. Greater than, less than or equal to, greater than or equal to. Those four things. So what does it mean to solve an inequality? It's just like an equation where you're trying to find the number or numbers that make the inequality true. Okay, and by getting the x by itself, getting the variable by itself, you'll be able to figure that out. But the difference with inequalities is that once you get the x by itself, all right, it's not all that obvious necessarily exactly what those numbers are that are solutions, okay? One of the reasons why that's true is because when you have an equation, if you end up with this answer here, okay, there's only one answer here. If you plug in 7 here, if you plug 7 into the variable, it makes the equation true. Okay, so it's obvious that x is equal to 7, that 7 is the solution. What we're going to see in this section, though, is getting x by itself. It could look something like this. It could be any one of these other three signs here as well in the middle instead of the equal sign. But this isn't all that obvious, okay? There's a lot of numbers that could make this true. The answer is not 7 when it comes to the solution. If I plug 8 into here, that's true. 8 is greater than 7. If I plug in 9, that would be true. If I plug in 6, however, it's not. Okay, so what I'm trying to point out here is that with inequalities, it's not enough just to get the x by itself. There's a few more things that we need to do in order to clearly illustrate what the solution set is. Okay, and I say solution set because there's always going to be an infinite number of solutions. Okay, not just one or two like we saw in the last few sections. No, it's going to be an infinite amount of them. All right, and so just like when we were graphing lines, which has an infinite amount of points on it, okay, we're going to need to employ a type of graphing here as well. But the difference is that we're just going to use a number line, as it says here in the directions. The reason why is because when we graphed lines before, we normally had two variables, x and y. Okay, sometimes one of them was invisible, but you always had two variables. Here you just have one. Okay, here you just have t. In this problem, you just have w. Okay, so you only need the x-axis, in other words. Not that you're always going to have the letter x, but it'll be similar to that. A number line looks like the x-axis, and that's all you need because you only have one variable. But we do need to graph it because that's, as we saw in the past, that's a good way to illustrate when you have an infinite amount of solutions. Okay. There's one more thing we got to do after that, mainly because it's just something that we're going to need to get used to for the future, and that's called interval notation. We saw a version of that earlier when we were doing domain problems. I'll carefully go through that when we get to that. Okay, so how do you actually get x by itself here when you have an inequality? Okay. Let's read the directions here. And this is just for not quadratic. This is just for linear inequalities here. So in other words, linear inequalities are just like equations, okay? Linear equations, that is. Linear equations are where each side of the inequality or equation, after you clear out the parentheses, has just, for example, t, not t to the second or t to the third, but just t, okay? It has a polynomial on both sides where you just have t to the first power. Again, no t to the second or t to the third, okay? Same thing here with linear inequalities, all right? The only difference is that you have the inequality symbol in the middle right here instead of having an equal sign. So that's a linear inequality. These all, well, these are a little bit different down here because they got 3 parts to them. We'll get into that in a minute. They're very similar though. But the ones where you just have one inequality symbol in the middle here, those are, like I said here, all the ones that we're going to see in this section will be linear inequalities. And that's important to know because we're going to talk right now about how to solve a linear inequality. It's so similar to a linear equation in the way that it looks, so it's not a surprise that since our goal, at least initially, is the same here, which is to get x by itself, the steps you would figure would be the same as well. But there's one big difference. In other words, so the steps are the same, okay, no doubt about that, but the steps you do are going to have one big difference here. It says if you multiply or divide both sides of the inequality by a negative number, keyword there is negative. If you divide by a positive, that they're not talking about that. Okay, that's just fine. But when you divide both sides or you multiply by a negative number, you must switch the direction of the inequality symbol. Okay, here's what I mean. Let's say that you had a problem like this right here. Doesn't this look like one of those steps right here in a linear equation where you would divide out to get the x by itself? But I'm divided by a negative, right? Since I'm divided by a negative, I need to flip that inequality around. So instead of it going this direction, it's now going to go that direction. All right. But if you divide by a positive, I want to make this clear here. Let me just show you a different problem here. If you have a problem like this right here, separate problem here. In this case, you divide by a positive, wouldn't you, to get the x by itself? You do not flip the inequality in that case, only when you are dividing by a negative, and you probably won't need to do this right now, but also it's true if you multiply by negative on both sides, all right? You're not going to need to do multiplying here on both sides of the inequality, but I just wanted to let you know that. But yes, that last step when you divide out, you're dividing both sides by the same number, you got to flip it, but only if it's negative. The thing that you're dividing by, only if it's negative. Okay, so and I'll mention what this stuff means right here. I added that into the worksheet here, but don't worry, I'll go over that carefully. That has to do with the last step here with the interval notation. So let's jump right into the first problem. Remember, this is a linear inequality, just like this one is. And so that means that we do the same steps that we did in Chapter 3 when we were doing linear equations, okay, Section 3.1 up to 3.3. Same steps. The only difference is we have to remember to flip the inequality around if we divide by a negative on that last step when we get the variable by itself. So let's jump into it here. We need to distribute -1 right here, just like we normally would in a linear equation. Like that. All right. Distribute the 2 right here. Again, just like we normally would. Then what does the linear equations tell us to do after we distribute out our parentheses? It tells us to combine like terms. So let me do that now. Then it tells us to what? It tells us to put the t terms on one side of the inequality and the 24 and the 6, or sorry, the 26 and the 14 on the other side. So I'll go ahead and move the t terms over to the right. Again, it doesn't matter what side you go. You can move the t terms to the left as long as you put the 26 and the 14 on the opposite side of wherever the t terms went. So that I get negative 5t here plus 26. And then I need to move the 26 over with the 14 like that. Okay, and I get negative 40, negative 5t. Oh, it looks like I'm going to have to divide by a negative, right? Okay, what does that mean now? Since I'm dividing by a negative here to get the t by itself, I'm going to get 8. And this thing right here needs to flip around the other direction like that. Okay, so I have 8 is greater than or equal to t. That's what it says. Okay, so hey, great, we got the t by itself. Fantastic, right? But what do the directions tell us to do? And these are those last two steps you got to do after you get the variable by itself. Like I said, you can't just stop when the variable's by itself because that doesn't really clearly indicate what the answer is. All right, we need to clearly illustrate it because there's an infinite amount of answers, like I said. So the first thing we do is put it on a number line. Let me show you that. Okay. So just draw a number line right here. What you want to do is take that number, and don't do this until you actually get the variable by itself. But once the variable is by itself, you take that number that's on the other side. You can, since there's only one number we're dealing with here, you can put it anywhere on the number line. It doesn't matter. I'll just put it right there. Since it's positive, I kind of put it over on the right-hand side where the positives usually go. But it's not a big deal since it's the only number that's going to be on there. You can put it anywhere you want. Okay, and now here's the key part. When you do a one variable linear inequality and you're solving it, okay, the graphing part will always be, you're going to shade in or color in either this side of the 8 or this side of the 8. You'll never shade in both sides. You'll never shade in a little bit of one side and a little bit of the other. No, it's going to be all on one side shaded and none on the other side shaded. So the only question now is which of the two sides is the side that you color in or shade, and then which of the two sides doesn't get touched at all, doesn't get shaded at all or colored in at all. Okay, here's how you figure that out. You do not look at the inequality only here. Okay, a lot of people make the mistake of saying, hey, that says greater than, and since greater than means the number's over here, I must shade over here. No, 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 no. No, that's not the whole story. Okay, you got to look at the inequality in relation to the variable. Because remember, you guys, in order for a number to be a solution, it has to be true when you plug it into the variable. Not into the 8. There's nowhere to plug it into the 8 here. Okay, there's no variable there. It's something is true if you plug it into the variable and it's true. So you got to look at the variable in relation to the inequality symbol. Now, pardon me here for a second, you guys. I'm going to say something that sounds a little bit childish. Okay, I know you're in college, all right. So, but this is something that makes it easy to understand, easier anyway. But when I was in first grade and I first learned about these inequality symbols, my teacher said that it was like an alligator mouth. Okay, and what does the alligator want to do? The alligator wants to eat, right? Okay, and obviously if the alligator has a choice between 8 and t, all right, the alligator wants to eat the bigger thing. So it looks right here like this is an alligator mouth that's eating the 8. That's why the 8 is greater than the t, or greater than or equal to t, because of that equal underneath it there. But so just like an alligator would always eat the bigger thing, okay, in this case it's eating the 8, because of the fact that the alligator is eating the 8, that means that the t is less than, okay, the variable is less than. That means that whatever number you plug in here, in order for it to be true, it must be less than 8, because the alligator wants to eat the 8 and not the number you plugged into the variable, okay, in order for it to be true. Okay, so for that reason, and don't worry, I'll go over that again, but for now, let me just shade the left-hand side, because remember, the left-hand side of the number line, you guys, is always where you have the numbers that are less than. The lesser numbers always go to the left, and the bigger numbers, the greater than numbers, always go to the right. Okay, so that's where students sometimes get confused. They see the symbol and they say, "Oh, hey, that says greater than. Don't I go to the greater than direction?" No, because the t is what you're really focused on here as well. All right, the t is less than the 8. All right, but that can be kind of confusing because the t is on the other side here, okay? And so that sometimes throws people off. So here's the main lesson, you guys. This will make it a real simple thing that you can remember here. If the alligator is not eating the variable, but it's eating the number, you always go to the left. Okay, because then that means that the variable is less than, because the alligator doesn't want to eat it, okay, and therefore the numbers that got plugged in must be less than, in other words, on the left, in order for them to be solutions. And we're trying to color in the solutions here, so we must therefore have to color in the less than numbers. Okay, so if the alligator is not eating the variable, you always go to the left. If the alligator had been eating the variable, okay, which you'll see on the next problem here in just a moment, then you would go to the right because that's the greater than direction, okay? So that's how you do the shading. Now, there's one more thing you got to do on the number line before you're done with the number line, and that is this thing called square brackets and round brackets. It's not going to be both in this step, but it's going to be one or the other. Okay, what you do is you look at the 8, okay, and you can't just leave it hanging right there. We need a special symbol there to indicate whether or not 8 itself, the number 8 itself, is a solution or not. Okay, if I plugged 8 into the variable here, would this be true? Is 8 greater than or equal to t? You don't have to write this down, but just so you can see what I'm thinking here. Is 8 greater than or equal to 8 when I plugged 8 into t right here? Okay. If I plug the 8 into the t, I get this right here, and this is true. Why? It's true because it says what? 8 is greater than or equal to 8. Okay, so when it has that equal to thing there, which I like to call alligator feet, okay, the feet of the alligator underneath his mouth, if it has alligator feet, in other words, a little equal to component underneath it, then you're going to use this is going to be true, and square brackets indicate that it's true. Round brackets is when it's false. And so for that reason, the square brackets are going to be what you use when it has that equal to component in it. Okay, alligator feet, in other words. So if you've got alligator feet right here, either one of these it doesn't matter which one of these it is. If it has alligator feet underneath the mouth, you're going to use a square bracket on that number. Okay, if this had not had the little equal to thing underneath it, if it had just said greater than only without the little line underneath it, then you'd use a round bracket. Okay, I'll get into why that's true here coming up, but that's what you would do. I'll explain this infinity or negative infinity thing here in just a moment. Okay. In fact, I'll explain it right now because we're done with the number line. The number line just required that we did the shading and then the bracket. So now, what do we do as far as the interval notation is concerned here? They asked for that last year. Interval notation is very similar to what we did back in section 4.6 when we did the domain and range, and we were looking at the graph here, and I had to do all that stuff there where you had the leftmost point and the rightmost point. We're not going to... Remember, the number line, you guys, is a line that goes straight across like an x-axis. It's similar to an x-axis. And we know that domain is related to x. So don't focus on the range here. What we're about ready to do is similar to the domain. And the domain was what? It was when we focused on the leftmost point and the rightmost point. Leftmost, rightmost, with the comma in between. That's what we're going to do here with the interval notation in this problem, because this is like an x-axis. Okay, and the domain dealt with the x's. And so let me give you an example which is very similar to this problem. Look at problem D right here from section 4.6. Notice that in two different places, in fact, the graph went forever to the left. In a similar way, this shading goes forever to the left because you have to shade the entire left side all the way down to the arrow here at the end of the number line. So this the shading goes forever to the left. We learned that when the domain or when the graph went forever to the left, the domain always started with negative infinity before the comma. No different here. When the shading goes forever to the left, our interval notation is always going to start out at negative infinity for the same reason. Okay, and then notice here that there is a rightmost point. It does not go forever to the right at all. Okay, the furthest to the right that the graph goes is this point right here, and the x value at that point is 0 because that's 0, 3 right there. So that means that the rightmost x value is 0, and that's what you put after the comma, the rightmost x value, the x value that is furthest to the right. In the same way, the 8 is the number that is furthest to the right on the number line as far as the shading is concerned. The shading goes all the way up to 8. 8 is the furthest to the right that the shading goes. And so in the same way, you put the 8 after the comma right there. Okay? Now, that's where we stop the domain problems. I didn't want to give you any more than that, but in reality, when you do a domain and range problem in the future, you're going to need to put brackets on each side of these two numbers right here. Okay, didn't need to do it there because that wasn't as important yet, and so I kind of just allowed you to skip over that. Wasn't a big deal. All right, but now that they ask you for interval notation, again, I do need you to do the official way in which you're supposed to do interval notation. I need you, in other words, to include the brackets. Okay, I'll show you how to do that here. So no brackets needed with domain and range, but now that you're doing interval notation again, we're a little bit more used to it now. I want you to do the brackets that are normally in interval notation anyway. Okay, let me show you what I mean by that. You need to put a bracket on each side of this. It's not a round bracket all the time like it would be with a ordered pair from a graph. No, it depends on what these numbers are and what they're doing. Okay, infinity and negative infinity are always round, always. Because remember, round, as I said a few minutes ago, means that that number is not true. All right, that number when you plug it in does not make this true. Now you might be thinking, hey, wait a second. If we plug in negative infinity, isn't that less than 8? Isn't this really true? Kind of, but the problem is that negative infinity is not even a number. That's not even a real number, all right? It's just a concept saying that it goes forever in the negative direction. So that's why we always use a round bracket with either infinity or negative infinity. Even though it's true right here when you plug it in, you're really not supposed to even plug it in at all because it's not even a number. T, you're only supposed to plug numbers or something that represents a number into that, okay? Not infinity or negative infinity, okay? So that's why those are always round. Infinity or negative infinity, you always put a round bracket next to that every single time. And then as far as the 8 is concerned, okay, you just use the same bracket you used up in the graph, okay, because it's going to be the same reasoning, okay? You use a square bracket if the 8 makes this true, like we already showed that it did. In other words, if the alligator's got feet, it's going to make it true, all right? And you use a round bracket if it's false. If this had been false, if there had been no equal sign underneath the alligator mouth, you would then use a round bracket in that case. So we are going to use a square bracket right there for the same reason as we use a square bracket up here. It's because the alligator has feet in this problem. Okay. So with the infinity or negative infinity part, you always use a round bracket on the interval notation. And then when you get to the number part, okay, there's always going to be one or the other in these problems. You're going to have either infinity or negative infinity as one of these two parts right here, okay? And then the other part will be just a normal number. When you get to the part with the normal number, just look at the graph and it'll tell you which bracket to use. It'll be the same bracket, okay? And that concludes interval notation, but don't forget those two brackets. Let's do that again. Let's solve this problem. How do I get W by itself? Well, just like a linear equation, we combine together the 11 and the 9 to get the W term by itself. We get this right here. The 9's cancel. We need to divide by a negative in order to get W by itself, right? And what does that mean once again? That means that the inequality symbol will flip around. If you forget to flip it around, the answer will be completely different and therefore wrong because the the direction that the inequality goes makes a big difference in the direction that your shading goes. All right. But we got W by itself. When you get W by itself, if you take the number that's on the other side of the W and you put that on your number line. Let's do that now. -1. Okay. And now, just like I said in the last problem, once you put that number on there, either your shading is going to be completely on the left side or it'll be completely on the right side. One or the other. Which one is it? Well, what did we say in the last problem? We said that if the alligator mouth is not eating the variable, you go to the left. But we also said that if the alligator, as you can see here, if the alligator is eating the variable, you can see that the alligator mouth is eating the variable, isn't it? Excuse me for being a little bit demonstrative here with the use of my hands, but I just want to make sure you understand what I mean by that. The alligator mouth is chomping towards the W, isn't it? Okay, and that means that it's eating the W, and when the alligator is eating the variable, we go what direction? We go to the right. Okay, because that's the greater than direction. And remember, if the alligator is eating the variable, that means that the numbers that you plug in have got to be greater than, because the alligator always eats what's greater. Okay, so the numbers that you plug into the variable have to be greater than in order to be true. And therefore, the solutions are greater than. Because remember, solutions are what makes it true. So there's your shading. But after you do your shading, you always have to remember to put that bracket on the number. Okay, it kind of closes up the shading, but it also indicates whether or not -1 is a solution or not itself. All right. If the alligator does not have feet underneath the mouth right there, it is not going to be a solution, -1 that is, and therefore you use a round bracket. Okay, you don't have to write this down, but if you plug in -1, isn't this false right here? Isn't it true that -1 is not greater than itself? It's greater than or equal to itself, but since the alligator doesn't have feet right here, that equal to part is not here. It's not in this problem. Okay, so this cannot be greater than itself, therefore that's false. Okay, and we use the round bracket when the number that the round bracket is sitting on is false. Okay, so the easier way again to remember it is if the alligator doesn't have feet, you use a round bracket on the number. But we always use a round bracket on infinity and negative infinity. You don't need to put a bracket over here when it goes forever in one direction. We just put the shaded in arrow right here. But on the number in the middle of the graph, that's where you put the bracket. So we got the shading. We got the bracket. That means we're done with the graph part. Okay, the graphing on the number line part where it says write the solution set on a number line. That means to graph it on the number line. And then put the solution set in interval notation. Remember, again, the interval notation means what? It means leftmost point, rightmost point. Okay, and as we learned back in, again, here's a good example right here. When the graph goes forever to the right, like we saw in the function section with domain and range, if it goes forever to the right, that means it's going to end at infinity on the right-hand side of the comma here. All right, same thing here. If it goes forever to the right, okay, it's going to end at infinity after the comma. But what goes before the comma? The leftmost point does. The leftmost point always goes before the comma. The leftmost point is right here in this problem. The x value right there is -2, and that's why I wrote a -2 before the comma right there. Same thing here. The leftmost number here in the shading is -1, and so the -1 goes before the comma. Leftmost point, comma, rightmost point. But you got to remember to put your brackets in there as well. Okay, infinity always has a round bracket next to it, as we already talked about. So put that there. -1, like I said, when you do the regular number but not the infinity number, and you try to figure out what bracket goes next to that regular number there, you just use the same bracket we used up here. So that would be round on this case. Okay. So that is solving a one variable linear inequality. Now you can see down here in these problems we have two inequalities, so that's going to be a little bit of a different problem. It definitely is similar though, that's why it's in this section. But let's not deal with that just yet. Okay, let's go ahead and try two problems that are similar to the problems we just did. On the second page here, we have problems 1 and 2. Please try those first. After we do that, then we will deal with those problems that have the two inequalities in it in the same problem. Okay? So do 1 and 2, hit the play button, and then we'll go on from there. Okay, number 1. We need to get the 3 and the 4 on the same side before we can divide out. So I subtract the 3 over, and I get 2x greater than 1. Since I now need to divide by positive 2, not negative 2, but positive 2, in order to get the x by itself, I do not flip this inequality due to the fact that I divided by a positive. You divide by a positive, you don't flip it. When you divide by a negative, that's when you flip it. So we get x is still greater than, and then 1/2 over here. So you take the 1/2, you put it on your number line right there. Why did I shade on the right side instead of the left side? It's because the alligator is eating the variable. When it's eating the variable, that means that the solutions are going to be greater than, okay, because the alligator wants to eat what's greater than, and it's the variable where you put the answers to see if they're true or not, okay? So if the alligator's eating the variable, it's greater than, or that's where the answers are, and therefore you go to the right. That's the greater than direction. And so after that, you put the correct bracket on the number itself, all right, 1/2. And since the alligator doesn't have feet underneath it here, you put a round bracket like always in that case. What's the interval notation, you guys? It is, oh, it's over here. The leftmost point is 1/2. The rightmost point, when it goes on forever to the right, just like on the domain graphs, that means that it ends at infinity after the comma, okay? So if it goes forever to the right, the infinity is on the right. If it goes forever to the left, like it did in the very first problem that we did, okay, then the interval notation starts with negative infinity on the left, okay? So again, it's very similar to the domain problems in that respect. So 1/2 comma infinity. Infinity will always have a round bracket. 1/2 is going to have the same bracket as you see in the graph here. Like I said, the regular number will, the number that's not infinity, that's what I mean by the regular number. The regular number will have the same bracket as you have in the graph here. So that's why I put a round bracket right here. Okay, just like we have a round bracket here at 1/2. Number 2. If I solve that, I have to distribute out the 3 first. I then combine like terms. I then move the b over to the left, or over to the right. You could have moved it over to the left. I'll show you that here in a moment if you did that. Okay. I then, because I moved the b terms to the right, I need to move the 9 over to the left here. And I get b is, negative 15 is greater than or equal to b. Okay, if you had decided, and that's fine, like I said, if you had decided to put the b's on the left instead of the right, your step here that you get after you move the terms should be negative b and 15. Negative b greater than or equal to 15. Okay, so it looks different than my answer, at least initially, but you still need to divide out the negative 1 right here in order to get the b by itself. And when you do that, you can see that you get b less than or equal to negative 15. Even though this statement looks different than the one that I have down here, it means the same thing because we have the same two things, b and b, negative 15, negative 15. So the same two things, b and negative 15. But it's also important, in order for it to be the same thing, it's important that the alligator mouth is eating the same thing. Okay, so notice that the alligator is eating negative 15 here, and it's eating negative 15 here as well. As long as it's eating the same thing, it's still the same statement. Okay, so it doesn't matter what side you got your B on. It could be the opposite side of where mine is, as long as the alligator is still eating the same thing, whether it be the variable or in this case, it's the number. Okay, for you, it's the number here. For me, it's the number as well. So we're both right. Okay, we're both saying the same thing here. We both have the same answer. As long as it's eating the same thing, then it's the same answer. Okay. But be careful with that there. If it's not eating the same thing, all right, then it's a completely different answer. Okay. But if it is, then you know you got the same answer. All right. But in either case here, the alligator's eating the negative 15. All right, and that is the correct answer. Otherwise, I wouldn't have it written here, right? So what do we do in that case? The variable, because the alligator is not eating the variable, we always go to the left, don't we? You can see my graph is going to the left here, not over to the right. Okay, so that's why I shaded it in all the way to the left from the negative 15. Why did I pick a square bracket, though? I picked a square bracket because the alligator's got feet. Okay, the alligator's got feet. You use a square bracket on the negative 15. All right, and then we do the interval notation after we're done with the shading and the bracket here in the graph. The interval notation means what? It means that you do the leftmost point to the rightmost point with a comma in between. The leftmost point, when it goes forever to the left, like we said, that means the leftmost point is negative infinity. Put your comma. The rightmost point here of the shading is negative 15 because it doesn't go any further to the right than that. Okay, and the negative infinity is always round. Put a round bracket next to that. And then the square bracket, I chose a square bracket here instead of a round bracket because the graph has a square bracket for the negative 15. So it's going to be the same. Okay, so that is, again, solving a one-variable linear inequality. Now, what we have here in these last few problems in this section is something that, again, is slightly different, but it has some similarities here. It has inequalities. It's still got one variable, all right, but it's got two inequality symbols. What that basically means, you guys, is it's kind of like two problems in one, okay? But you can treat the two problems essentially as one, and that's why this whole thing looks like one big problem here. But when you actually figure out what to do, I still want you to do the same thing that we did back in the previous problems here in this section. But I want you to pretend just for a moment here, pretend like just the first two parts, because you can see this is what we call a three-part inequality. You've got the negative 4, you've got the 3w minus 1 in the middle of the inequality symbols, and then you got the 3. So that's a three-part thing, all right? Because the inequality symbols break it up into three parts due to the fact that there's two of them there. So looking at those three parts, pretend for just a moment that we're just focusing on the first two parts. Ignore the 3 for just a moment. We're not going to ignore it forever, but ignore it for just a moment. And I want you to pretend that we just have these two parts and I'm asking you to solve that. What steps would you do if you did not have the 3 right there on the far right and you were just looking at negative 4 and 3w minus 1? Okay, again, pretend like that's not even there. What would you do to get w by itself right there? Wouldn't you add the 1 over with the negative 4 and then divide out the 3 after that? You would, wouldn't you? My point, you guys, is that you take those same steps, adding the 1 and dividing by the 3, and you do that to all three parts. So you would normally do that on these two parts if the 3 wasn't here. So just do it to this part as well. Okay? So when you have a three-part inequality, pretend like there's only two parts. Ask yourself, what steps would I do if there was only two parts? And then go ahead and do those same steps to all three parts. Okay? Because I know that a three-part inequality can kind of throw us off sometimes. We're not used to seeing three parts. Okay, so that's why I'm saying pretend like that third part's not there. Okay, then you're looking at something that you're used to looking at, a two-part thing. You figure out the right steps to do, and then go ahead and do those same steps to all three parts. Because you do have to do the same thing to all three parts. That's definitely true. Okay, so we need to add 1 to all three parts here. Because that's what you would normally do if there was just two parts, right? So we get this. Then we need to divide out by the 3. But again, you do that to all 3 parts. Since you are dividing by positive 3, you need to remember that you don't flip the inequality symbols in that case. Okay, so they stay the same direction. What does this mean? We got W by itself right in the middle. If you get W by itself in the middle, then you're on your way to doing the number line and the interval notation, just like before. But what does this mean, okay, when there's 3 parts like that? Well, it could come in one of 2 ways. Sometimes the bigger number's over here, but sometimes the bigger number's over here. 4/3, because it's positive, it's bigger than -1. Okay, but what's important, okay, and you need to make sure to flip your inequalities whenever it's necessary in order for this to happen. But you should always get, if you do it right, you should always get the variable in the middle. You should get the bigger number getting eaten by the alligator. See how the alligator's eating the bigger number here? But see how the alligator doesn't want to eat the smaller number? It wants to eat the variable instead of the smaller number. So there's 2 alligators here, in other words. This one is eating the bigger number. This one does not want to eat the smaller number. That totally makes sense, right? Okay. You'd want to eat the bigger number, but not the smaller number. If your alligators are doing that, if they are eating the bigger number and they're not eating the smaller number with the variable in the middle, okay, because that's where it's always going to be, then you've done it right. And the graph and the interval notation is actually pretty simple compared to the way it was in the first few problems. All you got to do is take those two numbers this time, instead of just one like you do in the 2-part inequalities. Okay, you take both of those numbers, bring them down here, make sure to put the bigger number on the right, because the bigger number always goes on the right when you have like an x-axis like this, right? Okay. After you do that, the shading will always go in the middle. It will never go all the way to one end or the other. Notice that there's 3 different parts to the number line now. There's not 2 parts like there was up here. Okay, because you only had 1 number on there. It broke it up into 2 parts. Now you have 2 numbers, and therefore it breaks it up into 3 parts. First part, middle part, last part here on the right. Okay, you're always going to shade the middle on these 3-part inequalities. Okay, but you got to make sure that your alligators make sense here. All right, they have to eat the bigger number, but not the smaller one. Okay. If you forget to flip the inequality when you divide by negative, that will not be correct, and so I can't give you full credit. Even if your number line comes out correct and all that, you still need to flip those inequalities when they're supposed to be flipped. Okay, we didn't have to do that here, but we will in the next problem. So we'll remember to flip the inequalities in that one, because we're going to divide by -3 right there. Okay, so make sure to do your work correctly. But yes, you always shade the middle in these 3-part inequalities. And then since both of these have feet, we're going to put square brackets on both of these. Each one of these numbers is separate though. Notice, like for example here, notice that one of the inequalities does not have feet and one does. Okay, so the way it works is if the alligator that's next to 4/3 has feet, you do a square bracket on 4/3. But if this inequality that's next to 4/3 did not have feet, if there was not a foot underneath the mouth of the alligator, then you would have used a round bracket on that. So in this problem, you're going to have one square bracket and one round bracket because only one of the alligators has feet and the other one doesn't. We'll get to that here in a moment. Okay. But there's going to be 2 different brackets. You figure out each bracket separately based on each of the 2 alligators and whether or not they have feet. Now, what's the interval notation? And I say that question because we've done the shading. We've done our 2 brackets for each of the 2 numbers. Okay, when you got the 2 numbers on the number line, you got to have both brackets. All right, so don't forget to do both. The interval notation is not going to have infinity or negative infinity this time because that's only when it goes forever to the left or forever to the right. Didn't happen this time. It's just in the middle here. The shading is just in the middle. So the leftmost point is -1. The rightmost point is 4/3. and that's it. You just got to put the brackets here. And since these are both regular numbers, not infinity, not negative infinity, you just look at the number line to see what brackets you need, and it's going to be the same brackets in the interval notation as well. Both of them are square then. Let's do one more here. How do I get the b by itself? Again, if it helps you guys, pretend like that 10 is not there for just a moment. And what steps would you do to get the b by itself here if it was just the 6 and the 4 minus 3b? You would subtract the 6 over, pardon me, you would subtract the 4 over with the 6, right? And then you would divide by negative 3 to get the b by itself. So you do those same two steps, okay? But you also do those same two steps with the 10 as well. So what did I say? I said that we need to move over the 4. In other words, subtract the 4 over because 4 was positive. We need to subtract it. But you do that to all three parts. So we get 2, negative 3b, and 6. And then what was that last thing I said we had to do? We got to divide by negative 3. Oh, but we're dividing by a negative. What does that mean? Well, since there's two inequality symbols here, two alligators, and we divided all three parts by a negative, it would make logical sense then that we would flip both of the alligators. So this one gets flipped. B is now by itself in the middle. The negative 3's cancel. And then this alligator flips as well. And you get this right here. Notice once again, though, you guys, that the alligator wants to eat the bigger number. Negative 2/3 is bigger than negative 2, you guys. All right, I know that because 2/3 is bigger. 2/3 is smaller than 2. But whenever you take two positive numbers, okay, 2 is bigger than 2/3, right? But if you make them both negative, the opposite thing happens. All right? Since 2/3 is smaller than 2, if you make them both negative, all right, negative 2/3 is now bigger. And I'm saying that to confirm that the alligator is eating the bigger number, but it's not eating the smaller number. That's the way it's supposed to be on these three-part inequalities, okay? Otherwise, you did something wrong. So since it is like that, and first of all, before I do the graph, what numbers do I put on there? Negative 2/3 and negative 2. But which one goes on the left, though? The smaller number does. Okay, don't just do it in the same order that you see here, okay? It always has to be the smaller number on the left, the bigger number on the right. Okay? Okay, so now what do we do after we get those numbers on there? We always shade the middle when we're doing a three-part inequality. Always shade the middle. And once we do the shading, we then need to do the brackets, just like we've done in all these problems. Okay, how do we figure out the brackets on a three-part inequality? You look at the alligator that's next to each number. The alligator that's next to negative 2/3 has feet, so that means that that alligator is going to be square. Or, pardon me, that number is going to be square. Okay, alligator feet means square. The negative 2 has an alligator next to it that does not have alligator feet. It just has the mouth only, and so that's going to be round, like always when you don't have alligator feet. All right, so round bracket, square bracket. Now let's do the interval notation, which we always do after we're done with the shading and the brackets. All right. Leftmost point is negative 2. The rightmost point is negative 2/3. Okay, no negative infinity, no infinity here because it doesn't go forever to the left side. It doesn't go forever to the right side. It's just packed in the middle here. Okay, but wherever the shading starts, wherever the shading ends, that's what you put in as these two numbers here with a comma in between. That's interval notation. Okay. Then for the brackets, you use the same brackets as we had in the graph here. All right. These are, again, just normal numbers, no infinity, no negative infinity. So since they're just normal numbers, you use the same brackets that are attached to those excuse me, use those same brackets that are attached to those normal numbers when you do the interval notation. Round bracket, square bracket. Okay? And that is how to do a three-part inequality. Okay? We got 2 more problems on the second page, very similar to what we just did. They're three-part inequalities. Please try those. Hit the play button, and we'll see how those come out. Okay, number 3. Again, pretend like the 7's not there if that helps you see what the steps are. Okay, if that was the case, then you would add the 4 over with the other 4 and then divide by 2. So add 4 and divide by 2. You do those same steps with all 3 here. Add the 4 first. You get 8, 2x, and 11. You then divide by 2, but since you're dividing by a positive, you do not flip the alligators at all. Okay, and we end up with 4 less than or equal to x less than 11 halves. 11 halves, by the way, because, and you could put this in your calc, you don't have to change the number, you can keep it as a fraction, but just to confirm that that's bigger than 4, if you put 11 divided by 2 in your calculator, that's equal to 5.5, which we know is bigger than 4. And so that confirms that this all makes sense, because the alligator is supposed to eat the bigger number, and it's supposed to not eat the smaller number 4. And you can see that that's exactly what's going on with these 2 alligator mouths right here. Okay, so we did it right. At least as far as the alligator mouths go. Make sure that your numbers are calculated correctly as well, of course. All right, and they are in this case. But then I put that on the number line. All right, remember the shading always goes in the middle in these problems, the three-part inequalities. All right, square bracket for the 4, because the alligator's got feet. Round bracket for the 11 halves here, because the alligator does not have feet next to the 11 halves here. And then the interval notation is going to be what you see right there. Okay? Leftmost point of the shading, comma, rightmost point. Use the same 2 brackets, okay, from the number line for the brackets and the interval notation. Finally, in number 4, okay, there we go. We, again, need to what? We need to divide by -4 to get the x by itself. So we do that to all 3 parts here. But when you divide by a negative, you got to flip those alligators, both of them. Okay, and you can see I did that. 1/2, because it's positive, is definitely bigger than -2. So it does make sense, all right? The 1/2 is getting eaten. The bigger number is getting eaten by the alligator, but the -2 is not getting eaten by this alligator. Completely makes sense, because the -2 is a smaller number. So we did it right. The shading therefore goes in the middle. Make sure the -2 is the number on the left here, because it's a smaller number. Both of the brackets are going to be round brackets, because the alligator does not have feet underneath it in either of these alligators here that I'm pointing at. Neither of them have feet underneath it, so you have round brackets on both. And then same thing in the interval notation, round brackets on both, because that's what the number line told us, that there's round brackets on both. Okay, and that's it. All right, so that concludes solving linear inequalities with one variable, and that includes the three-part inequalities as well, which, as you can see, do have a lot of similarities to them, but definitely some differences as well. So watch out for that when you study and when you do your homework. Speaking of that, let me know if you have any questions about this section. We'll see more about inequalities in the next section, but this time there'll be 2 variables instead of 1. Okay, so a lot of similarities, but there'll be some differences as well in that next section. So in the meantime, have a good day, take care, and we'll see you back here for that next video.